Hello, I'm Rakil from SCC. Today I'm going from CSC Data Science. Today I'm going to talk about the topic IPv4 and IPv6, the Internet Protocol version 4 and Internet Protocol version 6. Under the subject Computer Networks, which code is BCS 502. So let us begin. So what are the contents we are going to see? First, the introduction, then IPv4 addressing format, IPv6 addressing format, comparing IPv4 and IPv6 addressing, benefits of IPv4, challenges of IPv4, benefits of IPv6, challenges of IPv6, and then lastly, the conclusion. So let us see the introduction. So we will see the overview, like what is IPv4 and IPv6. They are the Internet Protocol version 4 and Internet Protocol version 6. So they are the versions of Internet Protocol used for identifying devices on a network. These two, these are two versions of the Internet Protocol used for identifying devices on a network. So let us see some history. That is how it evolves. Like IPv4 was developed in the 1980s and is widely used, while IPv6 was introduced in the late 1990s to address the limitation of IPv4. Next, what is the purpose of it? So, primary purpose of these protocols are to provide unique addresses to devices on the internet so that they can communicate with each other. Next, what is the relevance of it? So current context, if you are seeing, then with the exponential growth of internet connected devices, the limitations of IPv4's address space have become apparent. IPv6 offers a solution with a much larger space, ensuring the continued expansion and functionality of the internet. Transition. The transition from IPv4 to IPv6 is crucial as it impacts network design, administration, and overall internet infrastructure. Understanding both protocols is essential for network engineering, administrators, and anyone involved in IT or telecommunication. Now let us see the IPv4 addressing format. How it is like, what is the format for IPv4, the Internet Protocol version 4? The first the structure. So what are the bits it is using? So IPv4 uses 32 bits for addressing segments. So it is divided into four octets, 8 bits is separated by periods. Periods is basically the full stop you see. So let us see one example. So it is an example of an address like 192 point of period 192.168.1.1. It is the address for IPv4. So notation is dotted decimal format as you can see in the example. Now address space. The total addresses, like approximately 4.3 billion unique addresses are there. Then uses the address space is subdivided into classes A, B, C, D, and E. Now let us see the IPv6, the Internet Protocol version 6 addressing format. First, the structure. The bits it uses is the bits IPv6 uses 128 bits for addresses. Segments divided into 8 groups of 4 hexadecimal digits separated by columns. It's an example we can see the addresses. The example is 2001 colon 0 DB8 colon 85 A3 colon 0000 colon 0000 colon 882E colon 0370 colon 7334. As you can see, instead of the periods or the dots, it is using colons in the addresses and it is divided into like 8 groups 1, 2, 3, 4, 5, 6, 7, 8, 8 groups for 4 hexadecimal digits, as you can see. So the notation it is using hexadecimal colon separated format. Now address space. Total addresses like it is found approximately 840 undecillion, which is like 3.4 into 10 raised to the power 38 unique addresses. Then usage. The expanded address space involves the exhaustion issue of IPv. Let us compare the IPv4 and IPv6 addressing. In the left side, you can see IPv4 and right side, you can see IPv6. So address length for IPv4 is 32 bits, whereas the address length for IPv6 is 128 bits. So notation for IPv4 is dotted decimal, as you have seen previously as well. The example is 192.168.1.1. This is one of the examples. There are many are there. So in IPv6, the notation is hexadecimal colon separated. Like example is 2001 colon 0 DB8 colon 1 as you have seen previously as well. So now in address space for IPv4, it is approximately 4.3 billion addresses leading to exhaustion issues, whereas in IPv6, the address space vastly expanded space, effectively unlimited for the foreseeable future. Then IPv4, the complexity is simpler addressing, whereas for IPv6, the complexity is more complex, but includes features for simplification like zero compression, example colon 1. Now let us see the benefits of IPv4. The simplicity. First, the simplicity, the configuration is easier to configure and understand due to shorter addresses and simpler notation. Compatibility. The infrastructure is widely supported by existing network hardware and software. The transition. It is dual stack, which means the IPv6 can coexist with IPv4 during the transition period, allowing gradual migration. Now, but what are the challenges? Because now we know that we are also using IPv6. So, what are the challenges of IPv4? Addresses expansion. The limitation. The 32-bit address space is insufficient for the growing number of internet-connected devices. As the internet-connected devices are increasing, so it becomes insufficient to use 32-bit address space. Next is security issue. The security, the lacks built-in security. IPv4 does not include security features natively, relying on additional protocol, example IPsec. So we need IPsec as an extra feature or additional protocol. We have to rely on this for the lack of security. Then performance. The efficiency, the less efficient routing and network performance in large modern networks. So let us see now the benefits of IPv6. And the address space, the vast addresses provides a virtually unlimited number of unique IP addresses. As we have seen that it uses 128 bits, so that's why it gives a virtually unlimited number of unique IP address for the feasible features. Then security, it comes with integrated IPsec that is built-in support of for IPsec for enhanced security through encryption and authentication. Then the efficiency. So there are header structure and auto configuration. For the header structure, simplified and more efficient header processing. Then auto configuration supports stateless address auto configuration, that is SLAAC, for easy network management. Now, but still, it also faces some challenges. So let us see some challenges for IPv6. So the adoption, complexity, and hardware software issues are there for the challenges it faced by IPv6. So first, adoption. So slow transition. Gradual adoption due to compatibility and transition challenges with existing IPv4 infrastructure. Then complexity, learning curve. Initially more complex to configure and understand. Then hardware and software, upgrades needed. Existing hardware and software may require upgrades to fully support IPv6. We are still using many hardware and software which can only function greatly for IPv4 but not for IPv6. That's why we need upgrades and we need for adoption as well. Now, what are let us see some conclusion. Like summary, you can see the importance and significance of knowing these differences, the benefits, the challenges, everything. Those differences and the impacts on network administration, security, and internet growth. Like it helps in this all this as we have seen previously. The future outlook. So transition to IPv6. The importance for transition to IPv6 as the future of networking is very important because while the IPv4 addresses are becoming exhausted, IPv6 provides a sustainable solution to support the ever increasing number of internet connected devices. So that's all for today. Uh, Thank you for watching.